Hey y'all, happy Sunday. Hope everything is going well for you and yours. This is the portion of the show where we let YouTube send out the notifications via social media, let folks know that the broadcast is getting ready to start. We'll sit here and we'll count down the next 2 minutes before I push that button and go live. If you happen to be watching this on replay, go ahead and scrub past this graphic until you see my smiling face. If you have any questions and you're joining us today in the live chat, feel free to go ahead and add those questions to the live chat now, and we'll get to them in due course during this live Q&A session. So, sit back, relax, grab a beverage, and we'll get going in about 30 seconds. Hey y'all, happy Sunday. Hope everybody's doing well. Oh boy, a lot going on back here. A little bit of behind the scenes stuff going on. In that, for some reason, for the last 2 weeks in a row, my internet service provider, who shall remain nameless, I don't know what's going on, but all of a sudden my internet goes out at about, I go live at noon my time, Pacific time. About 11:25, 11:30, 11:35, the internet goes down for about 2 minutes, 3 minutes. And it's like, oh my God, now what? Why now? Why now? And it's just well, anyway, you probably didn't care about that, but it's a momentary panic mode that sets in. Why now? Well, anyway, so today I released my tramming video where I trammed the Gatton CNC, and I tried to anticipate some questions in the process, and apparently I failed miserably because I had a few questions right off the bat about, excuse me one second. Excuse me. Sorry about that. I had a few questions about why tram to begin with, and why was I tramming to that surface plate? Why not tram to the tabletop? Okay, a couple of machinists reached out to me and were talking about how they tram a mill versus how we tram a CNC router. The purpose for tramming is to get that router or spindle as straight up and down as possible, both front to rear and left to right. The reason I didn't tram to the table is because I don't care who you are or how long you've been building things, it is virtually impossible to get a perfectly flat level table. The variations in the materials that we use basically make that impossible. And in the case of my table, where I have 3 layers, each variation in each piece of material is going to throw things off, here and there. So tramming to the table could just introduce more of an error when it comes to the spindle being perfectly straight up and down. So by putting that surface plate on the table and then leveling it so that each time I went down and hit that surface plate with that dial indicator, that put the surface of that surface plate on a level plane in space. So that when I come along with a bit, I know that bit is straight up and down, as straight up and down as I can get it. Let me hold it off here so you can see the bit. And it's not cocked this way or that way. Because even if it's just an infinitesimal amount, like I said, the variations in the material, that error can be multiplied. Now, it doesn't really matter all that much on a small bit like this or a 1/8 inch bit or something like that. But even on this 1.25" surfacing bit, you don't need much of a variation at all to where you have one side cutting into the material deeper than the other side. And that's what leaves ridges in your material, depending upon which is off. You could have ridges running this way. You can have them running across your X. You can have them running back and forth in the Y. Or in the case of, for instance, nod, if your router is tipped forward at the top the way mine was, that means the front edge of the bit is going to be cutting deeper than the back edge. And that leaves rows of scallops when I'm moving the bit in the Y direction. So by creating the circumstance where my bit is nice and flat, I can then come back and flatten the table by surfacing the spoil board. If I tram to the table, my table may be off just a little bit, and that's all that it needs. Now, Marcello is asking the question, are you going to machine your spoil board now that you reset your router? Yes, and that's the whole purpose. And this is where I have to have the discussion with the machinists, because it's a completely different exercise. When you tram, say, a Bridgeport mill, your table is a precision machined or ground surface. It is nice and flat. My CNC router table is not. It's neither precision nor is it flat. So you set that mill, that head, the spindle on the mill, to that table, because you know it's nice and flat, it's parallel, it's straight. And the purpose of tramming on a Bridgeport mill is to make sure that that spindle is perpendicular to the table. The purpose of tramming a CNC router is to get that spindle straight up and down in space so that I can then come back and surface the table. So I don't reference off of the table. I have to reference off of a flat plane. And that was the purpose for shimming up and adjusting that surface plate. A mill doesn't have to go through that. And mills are made to be adjusted because you're going to adjust the head to angles when you're cutting, just depending upon the setup that you're using. If you need to cut an angle into the top of a piece, you may set it up in a vise with setup blocks and angle the piece, or you may put the piece in flat and angle the head. A lot of our CNC router tables are made on steel or aluminum frames. And in the case of industrial machines, it's guaranteed that they're made out of a nice heavy steel frame. But the surfaces that we actually put our material on are not precision ground, and they're not precision milled. We have to mill that table to make it perpendicular to the travel of the spindle. So that's the difference. And I've also heard it said that, well, if your table isn't flat and level, you didn't build it right. And that's like I said before, I don't care who you are, or who you think you are, or how long you've been doing this. Your eyeball is not good enough to notice 3,000ths or a surface variation in plywood or MDF or whatever you make your spoil board out of. So that's kind of a I won't say a red herring, but it is a non sequitur. I mean, precision machines that have 7-digit price tags have to be trammed. So, you know, all it is it's attempting to get that bit running as flat and smooth as possible. And Les Clemens here, exactly, he brings up, whoops, there we go. Remember, our tables are made of wood, and wood moves with temperature variations. So, let's see. IL Peleg says, but wasn't the shimming of the surface plate to begin with relative to the virtual plane created by the movement of the bit end? To a point, yes. Shimming of the surface plate is relative to the virtual plane of the spindle. And then, and that's why, where'd my, well, I don't know where I set my dial indicator. I put everything away. The tip of the dial indicator doesn't come to a sharp point, but it comes to a small enough point that it will register, and this was a mistake I made, it will register on an exact point on all four corners of that surface plate. Yes, that is relative to the quote unquote virtual plane created by movement of the gantry. But that's why that's why I did all the work that I did. I had to make sure that gantry was square, and the height at one side on my X was identical to the height on the other side of my X. I mean, you wouldn't believe the stuff I had to do to this machine after moving it onto a smoother floor, because it was way out of whack. As I said in the video, this corner right here, this front corner, was the highest point on the table, and it was a ½ inch higher than the back half. If it wasn't that far out of level, the table, I might have been able to get away with just surfacing the spoil board and be done with it. But because it wasn't, I had to go back through the entire machine and make sure things were level and make sure things were flat. It took a little bit of shimming of bolts and nuts here and there on my V wheels and on certain other mounting points and what have you, because it was built in place to that location. And then when I changed that location, it was completely out of whack. It introduced twist because, everything, the low spots on the floor were compensated for when I built it. And then when I brought it in here, that low spot wasn't there anymore. Now I had to compensate for it again. So Russell Faraday says, I guess this all assumes the Z rails are accurately vertical. Yes. And that's what I mean. I had to shim some of those out because, again, it was built for that location. And the X and Y rails correct in the respective plane. I did have to do a little bit of alignment work on one X rail, but the Y rails were still there. But again, that introduced twist because one leg was lower than the other and another leg was higher than the other three. So I had to remove that twist. That's why I built this router table the way I built it, so that I could adjust the corners and the front and the back and everything else. So let's see. Let's see. Marcelo says, I was in the marching industry. I think you mean machining industry for close to 40 years, and all new machines and any that we moved were leveled and trammed. Yeah, it's just a matter of course. It's just a matter of course. You have to do that. Let's see, go back here to Warren's Corner, had a question. He said, will you create your surfacing G code in VCarve? Yes, I will. And I posted a video several years back. I will post a link to it in this in the description of this video as soon as we're done live here. And that was how to create a spoilboard surfacing toolpath in VCarve. And I just wrote a note to myself to post a link to that video as soon as we're done live here. I do generally speaking design and draw everything in VCarve or Aspire. Now I've moved up to Aspire. And heck, I even, my Shades and Stash logo, where did I put it? It's hiding back here. There we go. I designed that in VCarve, then put it in my photo editing program and filled in the colors. So I don't do like Corel Draw or Adobe Illustrator or anything like that. So what can you say? Let's see. Dave Matthews had one here. Put an end mill in the router and turn it on. Jog across the ply in both X and Y to cut a T shape, 50 or so deep. The bottom of that T will be parallel to the gantry on both X and Y. Okay, and then tram off the bottom of the T. It's just as easy. That, you know, if that works for you, then great. You know, I just went ahead and did the surface plate thing because that's how I'd seen it done. So let's see now. Jim Brown says, hi, everyone. Can you, I think you're saying, can you use a granite stone? They are pretty flat. They are. It's just, as I said in the video, I needed the surface plate for a couple of other things. And I thought the time was right. The timing was right. Might as well go ahead and pull the trigger. And I bought it in either late, well, actually my wife bought it for me, either in late November or early December. And it was right around $40 there then at that time. Let's see here. Rick French, thank you for the $10 super chat. I really do appreciate it. Holy cow, Sargon, thank you for the $20 super chat. My gosh, you guys are the best people in the world. I'm telling you. I'm telling you. Let's see. And there are several ways of tramming. And as I said in the video, this is not the best way. It's not the worst way. It's just the way I did it because that's the way I was taught. And that's the way I'd seen it done. Now, Leo Steger, who's been a machinist for years and years and years, says when he trammed his router, he used a 1/4-inch cutter, cut 3 spots in the spoil board. I got to go find the rest of it. Where'd you go, Leo? Okay, there you are. Placed 3 ball bearings in the holes, then placed the granite plate on it, then indicated the router. That's something I have heard of, but I've not done myself. But I have heard of that method. And the reason for 3 and not 4 is because a tripod is easier to get all the same depth than 4. So I have heard of doing it that way. Another thing that I didn't do, and I didn't do it simply because I didn't want to get into the intricacies of how to program it, but I saw a comment by someone on the video, and they said, why didn't you program in the locations of the 4 corners of the surface plate into Mach 3 and then just jog it that way? Let the machine do the movements. The main reason was because I didn't want to get off on a tangent and showing how to program those coordinates into Mach 3 when I don't know what percentage of the people watching the video use Mach 3. I've never used anything like Carbide Create or Easel, and I wouldn't even begin to know how to program those coordinates in those softwares, or something like Carbide Motion or Universal G-Code Sender. or any of those. I wouldn't have any idea on how to do it for them. So I didn't want to introduce more issues. But yes, I could have very easily programmed the 4 locations and then just use simple G commands to move the spindle. And also, I was trying to show people that you don't have to do things like that. You can just move it around to a different location by jogging. In my case, I use an Xbox 360 controller. Your mileage may vary. Let's see. Let me get back up here. And let's see. IL says, I saw people that use wheels for moving their machines. It seems to me that unless you have a perfectly flat floor, that might be a bad idea. Or is there a reasonable way to do wheels? I'm not a fan of putting something like this on casters. Yes, it's still standing up on 4 legs, but I prefer something steady and stable myself. I don't know. I just, something tells me that's not a good idea, So I'm not really a fan of casters on power machinery anyway. Having said that, I have to have it on some, like my table saw back there. It's on casters, but it's also on a lift system that I push one pedal and it lifts the whole thing up on the casters. I move it into position, push another pedal and drop it back down, and it's standing on the 4 legs, not on those casters. And as Paul Coffey just said, the more rigid, the better. So Todd HCNC said, I thought about using a granite floor tile, just don't know how flat it would be. That was my concern as well. I've not done a lot of tiling work, and I did like travertine and slate, a little bit of granite here and there, but there are different qualities of granite, and for what I paid for it, I have no regrets in going ahead and buying it. Like I said, I needed that plate for more than just tramming. So, and as I said before, you don't need that surface plate to tram. Now, in my first video, I used a piece of 1/8 inch thick glass. I had a piece of 3/8 inch tempered glass that I was going to use. But as luck would have it, I broke it. So, shattered. And so I had to scramble to find a piece of glass to do the video with. And so I ended up using a piece of 1/8 inch glass that is not thick enough. If you go back and watch that video and you watch the gauge, watch that dial indicator when I move it around on the surface of that glass, you can see there's just enough spring pressure in that dial indicator to where the glass will deflect downward just a little bit. And it's like, oh man. But I'd already committed, so I went ahead and did it. And it worked okay. Like I said, I ran it that way for 3 years. So, or 4 years, excuse me. November was 4 years since I built the Gatton CNC. So, let's see. Benchmark Design says an X with 2 motor adjustment is critical to perfect circles. What's your process for doing this? In Mach 3, that's part of the slave process. It makes all those adjustments. All I have to do is make sure that the couplers are tight on the motor shaft and on my lead screws. And Mach 3 takes care of everything else. I've never had an issue cutting circles. You just have to make sure your couplers are tight on both sides. I also put slippage marks on the coupler and motor shaft and on the coupler and lead screw. I picked that up when I was in the Army working on helicopters. That is a fail-safe way of looking at a glance and telling whether a coupler has spun on that shaft. because the slippage marks no longer line up, and you can identify which one is giving you trouble immediately visually. So let's see here. I'm scrolling back to see other okay, here we go. Steve Caldwell says that's the reason for shimming to a flat plane. This takes out the non-level and non-flat bed out of the equation. Exactly. That's the purpose of the method. Exactly. In tramming a mill or something like that, you are tramming the head to the table because the table is a known flat, level, smooth surface. On a CNC router, it's just the opposite. You're tramming to a level plane to create a flat, level surface on your table. The table is not a good reference. So let's see here. Let's see. James Brooks says, hi, Mark. Can I use the tramming indicator, or do I need to get the separate dial indicator to level the granite? If you, okay, you can use that dual indicator, the Edge Technology Pro. I got the Mini Pro Tram, which is 1/4 inch collet. The full-sized Pro Tram uses a 1/2 inch collet, and it's a little bit bigger. It's 5 inches between centers of the probes, where the Mini is 1/4 inch collet and 3 inches between centers of the probes. They're the same price, basically, virtually the same price. I think there may be a $5 or $6 difference, but I'm not sure. The only thing about that, you can use that tramming indicator, but the only thing about that is to be absolutely certain that you're using the same indicator to take all of your readings. Now, the indicator that I have, it's a little Triton indicator. It was less than $20 when I got it 4 years ago. I don't think it's much more than that now. And I use it for a lot more than just doing this, than doing tramming. I use it for setting up all kinds of things. I use it for setting up, make sure my table saw blade is parallel with the miter slots in the tabletop. I use it then to set my fence, make sure that my fence on the table saw is straight and parallel with the miter slots. I mean, there's all kinds of uses for a dial indicator, and the tramming indicator wouldn't be really appropriate for that. So you don't have to have that tramming indicator, the Edge Technology Pro Tram. That's a luxury. And as I said, I got one to see if they were worth the hype I kept hearing about. And to me, I think it was worth the money, but your situation may be completely different. If you can't afford both, I would suggest getting the single indicator. And my old video, which is linked in the description box of this video, will show you how to use that to set tram. So let's see here now. Rick French had another question. Okay, the next step question, he says, surface the old spoil board, glue on new, then surface the new. Maybe. I will surface this spoil board, and it's going to depend on how much I need to take off to get a flat surface all the way across. And the way I'll do that is just take some chalk and just start in one corner and just draw squiggled lines all the way across. And then come in. I have 2 tool paths made for surfacing my spoil board. One removes 20 thousandths of an inch of material, and the other removes 10 thousandths of an inch of material. And I'll run that 20 first just to get a rough surfacing, and then look at it and see how much of that chalk is left behind. If I only need to go a little bit, I'll change the G code and put in the 10 thousandths of an inch pass and surface it that way. Then look at the spoil board. If the thickness of the spoil board, I don't know if you can see over here, I have my T-tracks right there. If the thickness of the spoil board has been reduced enough to where I'm in danger of hitting the T-track with a bit, then I may glue a piece of 1/4 inch on strips on top of this and then surface those. If not, if I still have a lot of meat in my spoil board, then I'll just run it as is. I don't baby my spoil board. I figure it's there to get chopped up. So by God free, I'm going to chop it up. Bob Hillhouse, thank you very much for the super chat, sir. You guys are above and beyond. I mean, that means more than any of you will ever know. Thank you. Let's see. Suicidal at all times, one of the best channel names ever, says, could glue to an unsurfaced, the surface you face, surface is all that matters. I use MDF, so it's got a relatively flat surface on it, just straight from the factory. And I've never had an issue with that coming loose. Now, I know I cheesed a lot of people off when I made this spoil board. I glued the spoil board down to the table, and then I surface it and machine it. If I ever need to add to it, I'll just glue some 1/4 inch MDF on top of that, surface that, and I'm good. Drive on. But inevitably, I got, well, what happens if you should need to remove a piece? My first thought is, why would I ever want to remove a piece? Second thought is, if I have to remove a piece, I have a CNC router. I'll just cut it out, put a new one in. You know, it's Dave Matthews is right on the money. Spoil boards are made to be spoiled. It's a sacrificial board. Now, there is one exception, and that is when I'm two-sided machining. And as I've shown in my previous two-sided or two-sided, for those of you who can speak, when I'm two-sided machining, I have a piece of plywood I lay down to be able to drill the locating dowel holes in. Because when I'm designing in VCarve or Aspire, I can't guarantee that I'm not going to put a dowel alignment hole right in the middle of one of my pieces of T-track. So just having a piece of plywood that's sacrificial that I can screw down to the table and then drill my locating dowel holes in that, I'm guaranteed not to hit anything. So let's see. John Thompson said, I watched one video and the gentleman used the mini and just blocked up one needle. Yes, that's a viable alternative. It really is. That's a viable alternative. And that's in reference to using the dual indicator for just going around and leveling out the spoil board or the surface plate. That is a viable option. So let's see here. Steve Caldwell says the bolt with eccentric nut idea allows easier adjust x-axis tilt. However, could one replace one of the bolts in most any router? I.e. Shapeoko Pro XL asking for a friend, grin, where to buy. I knew that was going to come up, and that was one of the questions I should have addressed. This router mount that I made is a prototype. I am not ready to, that's why I haven't done a video on it or anything like that. I'm not 100% certain that this is going to be the final rendition of this mount plate. I looked for an eccentric bushing basically based on the Avid CNC spindle mount. They have a separate plate that bolts to the Z box, the Z assembly. And then the router mount plate bolts to that. Much like this one, it has the 4 corners and a locating pin. And they use that eccentric cam to adjust tilt. in their spindle assemblies. I thought, well, if it's good enough for Avid CNC, it's good enough for me. So I kind of copied that idea, adapted it to my Gatton CNC, and then I tried a couple of various things. Now, again, I'm not exactly certain this is going to be the final rendition of this. And I'm not 100% certain that I'm not going to use some wood screws to lock those plates together. I just haven't gotten that far yet. When I do, for folks who, like me, have a Gatton CNC, I'll post it over in the Gatton CNC group. I will release DXF files so that anybody can cut one out. But, and if there's any interest here from other folks who may be making DIY machines and don't mind plywood, of course, that doesn't mean you can't machine it out of aluminum if that's your style. I'll put them on the website. So, but as it sits right now, I'm not sure that's the final version. Where I got the eccentric nut was the, I believe the website was called RPM Industries. I will look for that link and put it in the description box of this video. The thing is, there are several different eccentric nuts out there, and they run anywhere from $2 to, for some reason, $135, just depending upon what size you want. I got this. It's made for a 1/4 or for a 1/4 inch bolt in the center, and the outside diameter is 3/8 of an inch. So I have it. I drilled out the area to put that eccentric, and there is a piece of 3/8 inch inside diameter bushing mounted in there, so that eccentric cam is rubbing against that bushing and not on wood, which would just wear. So, like I said, I'm not certain that's going to be the final iteration of that mount. That's why I didn't release any plans or anything. So let's see. Somebody else had a question further up here. Okay, crankshaft. Just finished putting together a 32 by 32 from Vivor. I'm not familiar with them. Haven't trammed or cut my spoil board. What should I do first, if not both twice? Tram first. In fact, when I first built this machine, I built the router mount, then immediately trammed the router before I even laid down the spoil board. But you can mount the spoil board. You don't have to wait. But tram the router before you surface the spoil board, because the minute you add that spoil board, that's no longer an indexable surface, if it ever was. And you don't want to surface a spoil board in its current condition, then tram, and then have to surface it again. You're doing double the work. So tram first, then surface. Because again, the whole purpose is to get that table flat. Whereas on a mill, you're trying to tram the head to the table, which is known to be flat and smooth. So let's see. Steve S., you can purchase eccentric bushings and nuts at McMaster Car. Yes, sir, you can, and they will kill you on shipping. If you happen to live close to McMaster Car and can do a will call, or you can call them up and talk to them about shipping, then, excellent. But for me, it is not worthwhile to order a $3 part and pay $26 to ship it to me, because the closest McMaster Car is 800 miles away. So yes, you can get them there. Now, where McMaster Car shines is if you're ordering large quantities or ordering a lot of individual parts. Like if you're ordering weld nuts and you're ordering eccentric bushings and you're ordering lead screw or whatever, if you're ordering a bunch of stuff, they will combine it all and you get one shipping charge. But It's happened in the past where I forgot something. The little black plastic knob I've got on the top of my stepper motor so I can adjust my axes without the power turned on was a $2 knob, and I think it was $18 to ship it to me. So, yes, you can get them there, but it may not be the best place. But I will try to find the link to that eccentric bushing. I know I have it saved. I just got to remember where I saved it. And I'll put the link here. So let's go with the bushing. And they go by about 15 different names. I've heard them called eccentric bushings. I've heard them called offset bushings. They're all over the place. Brooks Martin, that's an excellent tip. Bandsaw blade guides use eccentric bearing system. Check them out, relatively cheap. Yeah, that's a good tip. Thank you for that. McMaster car plus living in Alaska equals bankruptcy. Preach, brother. Preach. How you guys do that in Alaska, I don't know. I've seen some of the prices up there. So everything is relative. So, Les Clemens, I see you're using metal shims. Are you sacrificing a feeler gauge for those shims? Yes, that's exactly what I'm doing. That's one thing I have about 13 of around here is feeler gauges. Where I got them all, I have no idea, but I've been collecting tools since I was a kid. And when you've got a bunch of stuff, floating around in your toolbox, it's easy to collect too many things. And so, yeah, I found the longest feeler gauge that I had, and I started sacrificing the blades out of that. It worked for me. Now, yeah, I could go order or go down to Napa and get a bunch of shim stock, but I figured the feeler gauge was a quick way to find out exactly how much shimming I needed to do. And Murphy's Law of Combat number 6. If it's stupid, but it works, it isn't stupid. So there you go. So let's see. I think that's about it. Were there any other questions on tramming? Or why or how or when or where? If not, I do have another question. Okay, here we go. I take that back. Benchmark Design says, but if you happen to jam one X motor and the other is free, now they're out of timing. How do you get them back into perfect timing? Okay. All right. So the gantry is parallel to the Y-axis. Thanks. Okay. For that, about all you can do, and I've done it on this, if you don't have limit switches on both sides, on your case, the X, if you don't have limit switches so you can self-adjust in parallel, then what I've had to do, because I don't have them either, what I've had to do was you have to shut off the controller because the power running to the stepper motors won't allow you to turn them by hand. Shut off the power, adjust that lead screw. The way I do it is I adjust the lead screw until it's more or less back into parallel, turn everything back on, move it up to the front of the machine, then use a machinist scale to line them up parallel. I've got machinist scales all over the place, just like tape measures, but to line them up and make them parallel again. Something I'm going to be adding to this machine, which I probably won't video because nobody but me is interested in it, is adding a second limit switch so that when I home the machine, both motors home independently and will self-parallel itself, square itself up. So I know some machines like Avid, if you're using their proximity switch system, it has that as an option. So let's see. Okay, I think that's EdMatt or ED Matt 675, when I was flattening a large oak board with a 2-inch flat bit, I had even cuts along the X path, as much as 0.1 difference. Wow, 100 thou. How do I correct that? That's exactly what I'm talking about with tramming. Now, you didn't mention if it was, say, along the X path, so I'm assuming that's side to side. That means that your bit is either cutting deeper on the front edge of the bit or deeper on the back edge of the bit. It just depends on were those ridges towards the front of the machine or towards the back of the machine. And that is, tramming will take care of that. That's why you adjust the nod, which is front to rear, and you adjust the tilt, which is side to side. Tramming, as I showed in the other video, link in the description of this video, is what fixes that. Because I'm here, let me go ahead and screen share. I have an image here that describes it better than I ever could. And that is this here. When your spindle is trammed nice and square, both front to rear and side to side, you're cutting like this, a nice square bottom. If it's off, in this case tilt, you're not cutting square. And if you surface your spoil board or a slab or something like that with a large bit, these ridges are going to be even more pronounced and spaced further apart. This is called shingling, because if you look at it from the front, it looks like rows of shingles on the roof of a house, each one overlapping the other. There is also something called scalloping, which is if your nod is incorrect, or depending upon how you're running machine, if the front edge or back edge is cutting in deeper than the other edge, this surface here would be rows of scallops. If you're running the bit back and forth, in this case in Y. If you run it side to side in X, you'll get the shingles. So tramming is what takes care of that. And this is a better demonstration than anything I could have come up with. And I don't remember where I got this photo from, but it was quite a long time ago. So that's the whole purpose of doing this. So let's see. Yes, that is what is happening. He said that is what is happening. So you need to tram your router or spindle head. And that was the purpose of the video I posted earlier today. And for a better demonstration and description, check the older tramming video, and there's a link to that video in the description of this video and today's earlier video. So let's see. Okay, is there a difference between what some refer to as milling marks and being out of tram? Yes, there is a difference. And that's simply because of the motion of the cutter. The cutter is spinning like this. And much like if you go to wax your car, you rub the polish off after it dries, you'll start to see little swirl marks. You're not cutting into the paint. That's just the motion of the machine, and it's going to leave little imperfections in the surface. And that's true with router bits, whether it's in a CRC or a router table or a handheld router. It's also true with saw blades. Not bandsaw so much. It will leave just straight or diagonal lines. But the motion of the blade leaves those swirl marks. So let's see. So no, it doesn't have anything to do with it being out of tram. It's just the motion of the blade, the circular motion of the bit as it's cutting the material. So let's see. Scott Malek says, if set to hard stops and slowly run into them, you can square your machine. Yes, exactly right. I kind of do that, or I used to do that on this machine with these bearing plates here on the end. Those were my hard stops. And then I added limit switches, which are the blue things there on the corner. And that has a little probe that, or just basically a quarter 20 or no, a 1032 bolt with a plastic end on it. And that's the trigger for the limit switch. So when I installed that, I could no longer do that. And I just haven't gone and added hard stops. But yes, that is actually a better way of doing it than using the machinist scale every time. Russell Faraday says, my y-axis screws are scored on the visible ends. If either side loses steps, the two scored lines don't match. Yeah, but which one now? You know, I use, what did I use? I used whiteout to draw little lines on the face of the coupler and along the motor shaft and on the lead screw. And I could just identify which one is loose from a glance. I mean, now your way, if either sides lose steps, the two scored lines don't match. If it works, it works. That's perfect. A lot of times there is no best way and there is no wrong way. There is no right way. It's just whatever works for you. And if you're getting the end result you want predictably every time, you're doing it right. Doesn't matter how, you're doing it right. So, Roger the Tinker says you need to get closed loop stepper and driver. I need to get a lot of things, Roger. All in good time, my friend. But you're at, yeah, I'd like to play. I'd like to play with servos just to see. I've heard that the difference is just absolutely crazy, but I'd like to just see, you know. Let's see. Just searched eccentric bushing on eBay. They are available. Yeah, they're available all over the place. Just comparison shop more along the lines for shipping than the price of the actual bushing. Because, I mean, you might save 15 cents on the price of the bushing, but if you got to pay $2.25 more for shipping, doesn't make much sense. That's all, you know. Todd HCNC, who is somebody I would like to get on here and talk to. So I need y'all to apply a little peer pressure to Todd. I would like to get him on the show and just talk, because he and I have been interacting, you know, intermittently, for a few years now. And I'd like to sit him down and pick his brain a little bit. So I need some peer pressure to work on him. No pressure, Todd. No pressure. He doesn't like it when I do that. Okay. I think that is about. Okay. Dave Matthews says auto gantry alignment is cool. I finally set it up on mine after a year or two. I may be talking to you, Dave. Thank you. So let's see here. Get back down here. Crankshaft says, I have limit switches on front and rear of all axes. I currently have the switches on the same side. Should I put them on opposite sides? For instance, let's just go with X, because you say that's your dual motor. Your positive limit switch should be on the same side as your negative limit switch. And that's simply because if your gantry is at a square, you don't want one side hitting that's not on the limit switch. So your positive and your negative limit switches need to be on the same side. So, and not all controllers will support auto alignment. So, let's see. Dave Matthews, I'm trying to fix an obsolete servo amp out of the wife's long arm quilting machine. At the moment, I really like steppers, no schematic, no support. And the used one is $600, went on eBay. Ouch. That's when it's time to just look into it and see about replacing it with something else. So, okay. Okay, Todd, legit. That's legit, maybe. And thank you for considering it. Now, we got about 5 minutes left here before I want to go ahead and end this. I have some style questions here. And that is basically today's video was a departure from what I normally do. It's just a personal preference thing of mine. I don't like long periods of silence, and I don't like screaming tool noise because I hear it all day long. So there were some long periods of silence when I was doing the time lapses and everything. I didn't add any background music. I didn't add any voiceover. I just let it go, but it was silent. What's your opinion on that? Do you prefer quiet background music like I've done in my previous videos, or do you prefer silence? And I will not be adding tool sounds. That just drives me up a tree. I even attempted one video where I brought in different sound effects, but even that got old and it bothered me after a while. I mean, like I started up my router in one scene and it was the sound of a Harley Davidson revving up. And another scene was the sound of a race car passing by. That got old too. I also want to know if the camera angles were good. This is an experiment. I've got some overhead. You can see one right there. I've got some overhead mounts that I'm mounting cameras to. And if the angles were right, if the angles are good, I need to know, or I'd like your opinion on that kind of thing. I think the lighting was fine. These LED shop lights are just the bomb. So I didn't need any additional lighting on the table. And I am going to be getting one of those little sports cameras. I'm not going to risk a GoPro because that's too much money to have fall off of a mount and land in front of the router bit and get chewed up. I'm going to invest in a little El Cheapo sports camera to mount on the CNC itself so it can follow the bit, for a couple more angles. But let's see. Camera angles were just fine. Silence is golden. Thank you, Grant. Let's see. Quiet angles were good, says James Brooks. Say Roger the Tinker, I hate louder noise than your voice level. I try to balance all that out. But it's not always possible. And I'm old, I drop stuff. And so you'll hear a loud clang, and I try to edit that out. Jim Rockland says, I'm fine with quiet. Tom, very light music. Well, that's what I usually put in. And I try to go for something neutral and I fade it way down so it's not obtrusive. But I tell you, one of the reasons why people use music so much in their videos is to hide editing. In that, for instance, another one of my personal things is I hate mouth noises. So when I'm talking and your tongue clicks against the roof of your mouth, or in the case of me with these new dentures, I'm still not used to them. I will go through and I'll edit out little segments where I've got teeth hitting or something like that. But then I have that little spot of absolute silence. And you can tell ambient room noise disappears and comes back for just a sec, for just a brief little flash there. And after about 4 or 5 minutes of that, it gets really annoying. So quiet music in the background hides that. You can't tell that it's happened. That's the main reason why I have used music in the background. So, especially during voiceovers. When I'm standing back away from the camera and speaking into the camera, there's enough distance there to where it really doesn't matter because you can't hear a lot of that stuff. So, okay, well, all right. Big Rush fan myself. Preach, Brooks. Preach. R.I.P. Professor. Okay, let's see. Okay, overwhelmingly, um, it's all good. All right. So sounds like a great day. Flight of the Bumblebee. Yeah, well, Todd, that's interesting because I can hear echo. If you can't, I'm happy. But I can hear echo still. I still haven't got this arranged. I mean, there's been so much going on behind the scenes. I haven't built my work table. I haven't built a lot of stuff. I'm still got to go get a cabinet to put all my paint and stain and stuff in. But thank you for letting me know that. All right. Let's see. How would you hide your accent? Don't hide your accent. Own that accent. Revel in it. I have absolutely, don't hide it. Glorify in it. So, okay. Let's see. Next week, and I wish I could get the rights to use the Bus Boys song. The boys are back in town, and the same with Thin Lizzy, but neither one of them will give me the rights to use the song. That's right. Rob Sandstrom and Shane Peters will be back next Sunday. We're going to do another live stream that is 100% dedicated to your questions. A few people have emailed me questions that I will go ahead and ask at the very beginning. But after that, it's going to be 100% your questions on epoxy inlays. We're talking everything from the tools they buy to feeds and speeds, to how they surface it after it's done, to how long a project takes, to design, to tool pathing strategies, and all that stuff. Next week, and that won't be their last appearance either. If Shane had his way, he'd be on with me every day. And don't think I haven't thought of it. Excuse me. But next week, programming note, next week's will start at 1 p.m., not noon, 1 p.m. Pacific, 4 p.m. Eastern time. And that'll be Shane Peters and Rob Sandstrom, my epoxy inlay gurus, and we hope to have a good time. I don't know how long we're going to run. Last time Shane had to take off because it was his wife's birthday weekend. We'll see what happens. Les Clemens, thank you very, very much for the super chat. You guys are just absolutely fantastic. I really, really appreciate it more than you'll ever know. So let's go ahead and wrap this up and say, have a good weekend, y'all. I mean, I know it's almost over, but you still got time. Get outside, make some chips, enjoy yourself, and hang around watching YouTube videos all day long, even mine. Oh, they're long and boring. See you next week with Shane and Rob. Y'all have a good week. Thank you, everybody who has hit those super chat links and everybody who has hit those donation links down in the description of all of my videos. I appreciate you. Until next week, y'all take care.